Welcome students. Here we are going to discuss a very important laws in this topic, algebra of sets. In this video we will discuss commutative laws. Commutative laws. So there are two laws here. One is A union B is equal to B union A, and second A intersection B is equal to B intersection A. So what we find basically here, only order of these two sets have been reversed here. Here A union B, order has been reversed, B union A. Similarly here in the second law, A intersection B, order has been reversed, B intersection A. These laws are known as commutative laws, and we can prove these laws very easily, very interestingly. Okay, let us see proof of this first law. A union B is equal to B union A. Here we will use the property of sets that if A is a subset of another set B and B is a subset of this set A, then it shows that set A is equal to set B. We will use this property of set. So here we will try to show that set in left hand side is a subset of the set in right hand side, and again we will show that set in right hand side is a subset of the set in left hand side. Using this property, A is a subset of B and B is a subset of A will imply that A is equal to B. So we are going to use this property here. So let us suppose that X is any element of the set in left hand side, A union B. And by the definition of union of two sets A and B, here X belongs to A or X belongs to B. This implies that X belongs to A or X belongs to B. Correct? Because X is here in union of two sets. There may be possibility that X may belong to both the sets A and B. Maybe. But if not, even then, at least X is belonging to either set A or set B. That is confirmed. But it's not necessary that belonging to in both the sets. That is common, not necessarily. But this is always true that if X is a member in A union B, then X is a member of A or X is member of B. Otherwise, X would not come here. Okay, and there will be no problem if you change the order. Here in first step, it is written X belonging to A, second X belonging to B. If you write it first, there will be no problem. It shows that X belongs to set B, then you will write X belongs to set A, and this implies that X belongs to B union set A. By the definition of union of two sets, X is belonging to B or X is belonging to A, so X will belong union of these two sets. Let us call it relation number 1. Correct? Now we'll start from right hand side. Next, let X is belonging to this set in right hand side, which is B union A. The same process we will follow here, that here X belongs to set B or X belongs to set A. This implies that again we can interchange the place, we can reverse the order, so we can write here X belongs to set A or X belongs to set B. So X belongs to, by definition of union of two sets, belonging to A or B means belonging to A union B. X belongs to A union B. Let us call relation number 1. Okay. Now, by relation number 1, you see what we are getting. X is belonging to this set implies X is belonging to that set, means A union B is a subset of B union A. How we can say that A is a subset of B? If any element belonging to set A is also belonging to set B, it means A is a subset of, that is the definition of subset. So by relation number 1, we are getting A union B is a subset of B union A. And by relation number 2, we have started from B union A here. B union A is a subset of, we are coming to this place, A union B, A union B. Now by combining these two results, what we get? We have already mentioned here. If A is subset of B, B is subset of A, it means A is equal to B. The same thing here we are getting. LHS A union B is a subset of B union A and B union A is a subset of A union B. It means that these two sets are equal. We get A union B is equal to B union A. So this first law has been proved here. This commutative law, first part, A union B is equal to B union A, has been proved here. Now we will see proof of second part. Here we will show that A intersection B is equal to B intersection A. We will follow the same process, this process. A is a subset of B and B is a subset of A, implies that A is equal to B. So here also we will try to show that if any element X is belonging to left hand side set and it is also belonging to the right hand side set, it means left hand side set is a subset of right hand side set. So let us write X is belonging to A intersection B. Take care, here we are starting from left hand side and we will come to right hand side, then left hand side will be subset of right hand side. Okay, so let X is element of A intersection B. This implies that X belongs to A and X belongs to B. The only difference is that in the first law we are using the word OR due to this union sign. Here we will use the word AND due to this intersection sign. Since you know that if any element is belonging in intersection of two sets, means X will belong to both the sets. So that's why you are using AND here. And this order may be reversed. There will be no effect in the result. So this implies that X belongs to B and X belongs to A. Correct? And if X is belonging to B and A both, then this implies that X belongs to B intersection A, intersection of both the sets, because X is common in both the sets. So therefore, what will be the conclusion? We have started from left hand side, X belongs to this set, and we are coming to X is belonging to right hand side. So left hand side set is a subset of right hand side. So you can write here, therefore A intersection B is a subset of B intersection A. Suppose this is relation number 1. Now we will follow the next process and we will start from right hand side. Let X belongs to B intersection A. Here we will write, it means X belongs to B and X belongs to A. Again we can reverse the order, the same thing, the same statement we will write, but order will be changed. So this implies X belongs to set A and X belongs to set B. And X belonging to both the sets means X is belonging to intersection of these two sets. So X is belonging to A intersection B. You see, here we have started from X belonging to B intersection A, and we are coming that same element X belonging to A intersection B. This shows that This shows that B intersection A is a subset of A intersection B. Relation number 2. Now recall this property of sets. If A is a subset of B and B is a subset of A, it means A is equal to B. The same condition here. This is a subset of this one, and again reverse order, B intersection A is a subset of A intersection B, means these two sets in LHS and RHS will be equal. So we will write here, therefore by combining 1 and 2, we are getting here that A intersection B is equal to B intersection A. So here second part of this commutative law is also proved here. So very interesting, very simple. You have understood it properly. Just you write down in your notebook also, so that you could have a very good command over the proof of this commutative laws. Okay. So thank you very much students for watching this video, and hope you might have subscribed my channel. If you have not subscribed it, please do it immediately and keep watching my videos and enjoy learning mathematics. Thank you very much. Wish you all the best.